So let's get started at 6:10. If you're looking for the Blockchain Fundamentals decal, you're in the right place. Today's lesson is a high-level overview on Bitcoin protocol and consensus. But first, I'm going to go over some syllabus stuff, because that's the best part, right? So what to expect when you come to class. You're going to have a attendance or reading quiz. So you're going to come in, it's going to be a Google form. You're going to tell us that you're here, and only you are here. And then you're going to take a quiz on the reading that you had the night before or the week before. And that's going to happen every week except for this week. So there was no assignments, no nothing. This is going to be the majority of your grade. This is like 60% of your grade. So if you do this every week, you're basically guaranteed to pass. Then we're going to lecture for 60 minutes. I know it's a long time, but you know, it's not too bad. The technical slides we're going to put in black, so that's a sign for you to maybe stop taking notes and just pay attention to make sure you can really like let the material sink in. All questions are welcome, but if you have a sort of diving deeper question, I'm going to ask you to hold on to it until discussion, which happens right after lecture. We're going to have a lot of really awesome TAs come up with really cool activities and ways for you to get more involved with the material. And then you're going to have homework every week. It's going to be like maximum required reading, like 30 minutes. If you do this reading, you're going to pass the reading quiz. And if you want to do more, we can give you all kinds of other supplemental materials for you to dive in more. All right, so how to pass this class. This is a PNP class because it's a decal. You need 70%, no more, no less. So like I said, attendance, 30%. We give you 2 free passes, so if something comes up, you don't need to email me or anything. I'm going to ignore it. Just don't come, just 2 times, and we'll give you a free pass. Reading quizzes, you only need 4 out of 6 to get full credit. So don't worry if you didn't get all the questions right. You're going to get full credit as long as you basically, you know, read through the material and kind of get it. And then we have 5% participation. So this is super easy. If your TAs know your name, if I know your name, you're going to get full credit. And the last thing is the final paper or project. However you want to show that you were paying attention and learned something in this class. It's 35% because we want to make sure that you do this in order to pass the class. So basically, if you come to lecture every week, you pass a reading quiz, you turn in some kind of final, you're going to pass. So very easy, right? Yes? Okay. All right. Now, that being said, we do have some expectations for you. But first of all, what you can expect from us. This is Blockchain Fundamentals, so you can expect to get a fundamental understanding of blockchain, or more if you put in more work, right? What you put in is what you get out. We're going to go over high-level theory, a lot of CS concepts. We're going to go into crypto economics, all that kind of stuff. And we're also going to go into the technical details. So what does a Bitcoin script look like? What does, you know, a transaction really look like in Bitcoin? We might go through a little bit of code, but if you're not a CS major, don't worry. We're going to have, you know, all kinds of guidance through everything. So don't worry about that. And this is also, in my opinion, the best bang for your buck and time and unit. This class is only 1 unit, but we go through a lot of material and you're going to learn a lot, especially if you pay attention in class. That's the most important thing. And speaking of, what we expect from you. I expect you to come to class and pay attention. I'm going to ask you guys questions. I want you guys to be engaged, and that's how you're really going to learn the material. Like, at the end of this decal or whatever, you're going to be a blockchain expert. That's how easy it is to become a blockchain expert. You take this class, you read the material, and you get it. You're going to be able to go to any, like, big CEO, boss, or whatever and say, like, yeah, I know how Bitcoin works. Like, hit me with the questions, man. So yeah, please do engage with us. Come to our office hours, you know, go on Piazza, ask all your amazing questions, and we'll do our best to answer them. And we don't expect any kind of CS background. Like, how many of you guys here are not CS or EECS majors? Yeah, so we're all in this together. Cool. That being said, if you agree with all these expectations that I just listed, at the end of today, I'm going to give you an enrollment code. You need an enrollment code in order to go on Cal Central and enter in the permission code so that you can actually get your enrollment through. I have plenty to go around, but I can only give you 1. So, and if, is that Dev? Hey! And if you feel like you already know everything about blockchain, like Dev, or you feel like you can't come to class every week, you know, maybe save an enrollment code for someone else. All right. So who are we? I think this is a fun thing to talk about. This class is brought to you by Blockchain at Berkeley. We are a student-run organization on campus. We have 3 departments. Education, which teaches this decal along with other online courses and developer courses. We used to teach a developer decal, but just to be clear, that's not happening this year. We also have a consulting department because we are really considered subject matter experts in the industry, so a lot of external companies will come to us for advice and we'll help them build out proof of concepts and their own blockchain solutions to help them in the industry. And then we have an R&D department, which Dev is a part of, and so we really try to push the boundaries of the blockchain space knowledge. So we do a lot of really cool projects. This is kind of officially what our organizational structure looks like, but to those of us who work in education department, we think it looks like this, with education at the center. So if I were to say that there's any kind of starting point or entry point into blockchain at Berkeley, it really is, or the blockchain space, it really is this decal. A lot of people in our organization first took this decal, had a really great time, engaged with the material, applied to blockchain at Berkeley, and some of them are working with like big Fortune 500 companies, some of them are conducting research, and some of them teach this decal, like Brian. So they come full circle. Yeah, and then who are we? These three people are going to be up here talking. The first person is me. I'm Gloria. Jillian's not here today, but she's also super cool. Brian, do you want to introduce yourself?
Hi, I'm Brian. I taught the decal last semester too, and we hope to have a good semester.
Yeah, so that's something all three of us actually have in common. We've all taught this class before, so we kind of know what we're doing, and we kind of know what kind of questions you're going to ask, and we kind of dealt with the administration of everything before. So we've kind of streamlined this class and made it more optimized for a better use of your time as well as ours. So exciting. Anyone have any questions on syllabus or enrollment? Yes?
I know that you guys have an online course on identity.
We have an edX course.
Oh, okay. So
Yeah.
I'm wondering, what's the difference or is it common similarity does this class have with that one?
The course is a little bit different. I think the edX course might cover a little more material. Nadir, correct me if I'm wrong.
Yeah, so for those of you who don't know already, we have an edX version online. The first half of Blockchain Fundamentals is up there. The second half is coming out at the end of this month. It's basically the same material, just presented in a different way. This is much more, I would say this is much more helpful because it's interactive and you can talk to people. But if you're interested, I think there might be a way to finagle units out of taking the online version. But either way, I would take this version because you're here in Berkeley, and this isn't an opportunity to get anywhere else.
Yeah. Another question?
Can you tell us more about the project that previous students did for the final?
Oh, okay. So in the final, we limited it to basically a flesh out a use case, basically. Take what you've learned about blockchain and talk about how you would use it in some kind of industry or use case that you choose. For example, maybe I'm interested in supply chain use cases. So I'd say like, oh, like I think we could build something on Ethereum because, it's a public blockchain, and then it would be available for everyone to use, and the script it would look like this, something like that. This year I think we want to make it a little bit open-ended because not everybody loves to write essays, so we're thinking maybe if you build out a smart contract or something, we would accept that too as a show of your learning. Yeah, don't worry too much about it. That's a problem for December, right? So yeah, any other questions? All right, don't hesitate to ask. Oh, yeah.
So we're new to decal. How does it work with the slides? Are you posting them online? Is it on Cal?
Yes.
How does that work?
Yes, so we have a website. I can write it on the board later. It's called blockchain.berkeley.edu/decal. And that'll show you the website for this semester's iteration of this class. And every week we're going to post the slides, a video, as well as the discussion worksheet, I believe. Yes. So everything is available online. If you miss a class, you'll be able to catch up. Yes?
Is there any precedent for non-Cal students getting credit through this course?
I don't think you can enroll if you're not a Cal student, but yeah, I don't know. I mean, you can go ahead and say, I've taken this class. So, yeah. I don't know if we don't have any official certificate or anything. Yeah. All right. If you have any other questions, email me at gloria@blockchain.berkeley.edu, and I will answer them. You can also post in Piazza. So at the end of the day, I'm going to invite you all to our Piazza. Okay. So let's get into actual course content. Today's lecture, like I said, is on Bitcoin protocol and consensus. So at the end of the day, you're going to be able to tell someone exactly how Bitcoin works and why it's important. So, very easy. Okay. Here's a little timeline of how it's going to go. First, I'm going to give you some definitions. Maybe you're dying to know, what really is blockchain? I will answer those questions. And then I'm going to break down banks as well as Bitcoin into 4 different components. And we're going to step through each of them and see that they do kind of the same thing, just in different ways. All right. So first of all, what is Bitcoin? The formal definition is Bitcoin is a cryptocurrency, the first successful cryptocurrency built by Satoshi Nakamoto in 2008. Now, what is a cryptocurrency? Well, it's a currency, it's digital, and it uses computer science for efficiency, cryptography for security, and economics for incentive alignment to make it work functionally as a currency. And why it matters? First of all, it's purely digital. That's, not anything new, but the most important part is it's not controlled by any central entity. Now, why I say this is really important is, let's say I tell you, oh, it's a peer-to-peer transaction network. That's what someone told me once. And I went home and I told my friend exactly how Bitcoin worked. I told him everything I knew. And he said, isn't that just Venmo? And I did not know how to answer him. And the answer is, well, in Venmo, even though it's peer-to-peer, right? It looks like you're sending money directly between you and your friends, but you're actually still going through PayPal, which is the company that owns Venmo. You tell Venmo, I want to send this much money, and they handle everything behind the scenes, and they control exactly what the numbers are that you see on your screen. In Bitcoin, it's different. There is no central entity controlling everything. There is no central point of failure, as we say. So you're actually connected peer-to-peer, and we all come to decisions on how the transactions are working in a non-centralized manner. I'll go more into this later. But this sort of ideologies behind why we want a decentralized governance model comes from the cypherpunk movement, which was a libertarian ideology that came about in the 80s and 90s. The idea is we want to use cryptography to protect our privacy, and we are very distrustful of big banks and governments that can screw us over. So one of the things that we want is a currency, some way to transact with one another and keep track of how much we're spending without having to go through some kind of big institution like a bank. And Bitcoin was the original blockchain. So it used to be, if I said the blockchain, I meant the blockchain of Bitcoin. But now it has a lot of different meanings, right? So what is blockchain? I like to say that blockchain is a method of storing data amongst multiple parties that ensures data integrity without requiring trust. There's a lot of words, but basically, blockchain is like the data structure that we use to store transaction data in cryptocurrencies, such as blockchain. And the way that blockchains are structured are you can store data in it, and then it cannot be changed, or it's at least tamper evident. So once you've committed data into your blockchain, it cannot be changed. It's also a distributed ledger, which basically means that everyone holds a copy of the blockchain. So it's shared amongst everyone, it cannot be changed, and there's no central point of failure. I'll go more into this. But usually when someone says blockchain, they usually mean the technology behind this whole decentralized network of transacting with one another. And then you're also going to see other buzzwords come up, like anonymous and trustless and consensus, all this stuff. Like, I'm sure some of you had heard these words from someone talking about Bitcoin or blockchain. By the end of today, you're going to be able to take all these words and piece them into your knowledge of Bitcoin and blockchain. So that'll be fun. Now, let's talk about how currencies work. First, I'm going to give you the bank model. So what do we expect from a bank? First of all, identity management, right? We register our personal information with a bank. They take our social security or whatever, and they set up an account for us, and that account has some amount of money in it. They might have a checking account, a savings account, whatever, but we all have our own personal identity that is managed by the bank. The next part is what we want a bank for, being able to send money between people. We want to be able to transfer money from us to another person and receive it as well. And the third part is accurate record management. So banks are always heavily audited, so they keep a very clear history of all the transactions that have happened. This is very given, right? And the fourth part, which is kind of the part that people kind of get snagged on, is the trust. So we all know that banks are very heavily regulated by the government, and there's certified professionals behind all of the actions that are happening that are making sure that our money isn't stolen or there isn't some fraudulent transactions going on. So we need to trust some person or at least some entity taking care of our money. Now, how do we do this in a decentralized manner? We can. That's the first thing. So in Bitcoin, it works a little differently. We still have identity management, but instead of registering our personal information, we use private and public keys and addresses. I'll go more into this in detail, obviously. We still have transactions. It's just that the structure of it is a little bit different. And instead of a centralized database, we have a distributed ledger, and we use a blockchain to keep track of the data. And finally, instead of having trust in professionals or people handling things, we use a consensus protocol to come to a decision on what exactly is the truth, what actually happened, what transactions happened. Okay. So do we have any questions so far? Okay, good. So let's dive right into identity first. First of all, what's the role of identity in the context of currencies? I talked a little bit about it. Does anyone want to shout out an answer? Participate.
Well,
Yeah.
You're a partner in the transaction.
Yes.
Or a participant in the transaction.
Mm-hmm.
You have to know who you're talking to.
Right. Exactly. You have to make sure that you know who you're talking to. I saw another hand somewhere. Yeah. Yeah. Exactly, right. Okay, so here's basically what you guys said. We need to use this identity to receive money and claim money that's ours, and we need to assign blame. What I mean by that is if something happened in the past and someone signed off on a transaction, we need to be able to point to that person and say, hey, you did this because we have a signature proving that you were the one that did it. So we need to use our identity to authenticate our own transactions as well as claim things that belong to us. So we have kind of a private-facing identity and a public-facing identity. So some analogy to make this make sense. In our emails, we have an email address that people use to identify us. So they'll say, my email is Gloria, blah, blah, blah. So they'll say, okay, I'm going to send an email to Gloria. But for me to send emails to other people, I have to provide a password. That is my private-facing identity. And that is unique to myself, and that is the part that only I can prove. So when we go through a bank, we prove our identity through a social security number, our name, our birthday, our address, and the bank makes sure that they are indeed dealing with someone who exists in the real life. They also make sure that there's only one of you and you only have one account. And they're also going to make sure that if you have one username, someone else isn't going to have the same username because that would be very confusing. Well, in Bitcoin, it's a little bit different. So in Bitcoin, you actually will generate a private and public key pair. Your private key is going to be your private-facing identity, and your public key is going to be used to generate an address that people use to send money to you. Now, this private key is actually generated at random, and then the public key is just applying a function to get a public key. So you'll take, some kind of generator with a lot of entropy, and it'll give you a random key. There's no, I want my key to be like purple unicorns 182 or something. It's just randomly generated. So a few things that we want to know is no personal information is required. So anyone can go on Bitcoin and generate an account for themselves. So you might want to think like maybe Bitcoin is anonymous, and that is one of the goals of this kind of currency. We want to protect our personal information. There's a little more nuance to this than just, oh, it's anonymous, but we'll go into that later. There's also no limit to how many accounts you can make. You can apply this cryptographic function as many times as you want and generate as many keys as you want. And there's also no restrictions on which, sorry, I'll get to that real quick, which keys have already been taken. So there's going to be a question that says, what if someone has the same key as me? And I'm going to answer that. So first of all, your question? Oh, that was your question. Okay. Yeah. So, yes, you have a question too?
Everybody who uses it has to keep a copy of the ledger. Then doesn't that hold like high requirements for like your hardware?
The short answer is yes. That's kind of a question for maybe a later lecture. I don't know what you want me to say right now.
How do you make sure that it's widely accessible? If suppose if somebody wants to deny access to other people by like creating a lot of keys, like a lot of accounts, in order to increase the value of the system.
Right, okay, so there's another question about making a lot of accounts. So that's actually my next slide. So is it okay if I just answer that question right now? All right, so what if someone guesses my private key, or what if someone has the same private key as me? Well, I have this picture of the globe. This is the Earth, and there are a lot of grains of sand on the Earth. So asking what if someone guesses my private key is a little bit equivalent to saying, let's say everyone pick a random grain of sand on the Earth. But it's actually, what if for every grain of sand on Earth, there was another Earth with all the same grains of sand on the Earth? So it's like a lot of grains of sand. And even if this was the entire set, and I told you all to pick as many grains of sand as you want, that would still only be scratching the surface of how many possible keys you can generate in Bitcoin. So there's 2 to the 160th possible addresses that you can generate. That's a lot. So for context, if every single person in the world wanted to generate as many keys as they want, let's say I just started generating keys on my computer right now. I just kept going. I could have pretty much as many as I want, and there's no real point. And also the thing is, let's say you have, someone has this private key. It doesn't really matter unless they've actually put Bitcoin in that address, in that account. So the short answer is yes, if you have someone else's private key, you have access to all their Bitcoins. But it is statistically impossible for you to accidentally have the same private key as somebody. Does that answer your question?
Yeah.
Yes.
Is a key like a string, just like a word or a phrase, kind of like a password?
Yes, yes. Yeah.
Okay.
So it'll be like, so the question was, what does a key look like? It'll be like 2K1365H capital R, you know, like a very long string of random characters. Another question?
What's the point of randomly generating a key instead of having people assign their own?
I mean, so it's actually, I think it would be, it's even better hidden if you just randomly generate than if you were to have some kind of central registry. So that would be introducing centralization, right? Some kind of central registry of like all of the taken private keys. That just wouldn't make sense in a decentralized system. That's my answer. There might be other answers. Yeah?
Is there any shelf life for the public?
Shelf life.
After they generated, do they exist for infinite?
I'm pretty sure there's no expiration date or anything, no. Yeah, so that's all the questions. Really good questions, yeah. Okay. All right, so are there any more? Yeah.
So the 160 and 2 to the 160, was that arbitrary? Just a number of bits?
Yeah, so there's it's 256 bits, so there's 2 to the 256 possible keys, and then we are going to hash that using RIPE-ND 160, which turns it into a 160-bit long address. So that's how many addresses there are. Yeah. Yeah?
Well, if anyone can have as many keys as they like, I mean, it's theoretically possible for one person to generate enough to have the 51% attack.
So actually, 51% attack, that would be if your voting power was based on how many accounts you had, and it's not. Yeah, I'll get into that. Really good question, though. All right. So let's move on to the next part, which is transactions. Sorry, you had a question, too?
I'm just curious, is the key the same thing with the term identity you just talked about? Is one key, like, assign one identity to, or an identity is a person
Right.
behind that identity?
Okay, so I think The whole idea, so the question is, oh, if a key is an identity, is that equal to one person? So the idea is in Bitcoin, identity is not equal to one person. It's equal to a key. So one person, you're right, can be as many keys as you want.
Well, but then in that case, you also mentioned that identity means to you can assign a blame to this identity
Right.
if it did something wrong. But then, like, if a person is like committing a crime, and then you can maybe delete his address, but then and then delete his key, not address. Then you can just get a new one. So basically, you can keep committing crime.
Right, so what I meant by blame was if you see that someone signed off on a transaction, you can blame the transaction on them. Let's say someone bought, so you're talking about crimes, so let's say someone used Bitcoin to collect ransom after they kidnapped someone, or let's say they use it to buy drugs or something. So that account is still responsible for making that transaction. Even though you cannot exactly tie it to a person, you can kind of do that. Let's say if you track the IP address, for example.
You still need a central government to keep the order.
Yeah, so like I said, Bitcoin's ideologies are very libertarian. So the whole idea is nobody can control us. Yeah, so there are some problems with that. Yes, there is crime that happens and stuff, but the point is that nobody can control it. Yeah, there are ethical issues, there are questions like that, but the straight answer is that, yeah, no, you can commit crimes on Bitcoin, yes. Yeah. But one thing, you cannot delete your key. I just want to make that clear. Okay. All right. We ready to move on? Okay. So let's talk about transactions, sending and receiving money. First I have a question. What makes a transaction valid? Let's say I tell you, I want to send this much money to this person. What would you check for? Anyone?
If they have enough money.
If they have enough money, exactly. Anything else?
If they said that's okay.
If they said that's also one of them. Okay, so that's pretty much what I was looking for. First, we have proof of ownership. So they actually own this money, and they are the ones that signed off on this transaction. We look for a valid signature. So we look for a signature using that private key. The next thing is available funds. And the third thing is a little bit tricky. It's no other transactions using the same funds. So let's say I have $10 in my account, and I say I want to send $10 to Brian and $10 to Nadir. And then I tell you that I want to send $10 to Brian, and I tell Nadir I'm sending $10 to him. Technically, unless the transaction already went through, I still have $10 in my account. So what if they go at the same time, right? So we need to make sure that we're not spending the same money twice. In a bank, the way they would do this is we have an account for me and an account for Brian. And if I want to send $10 to Brian, then they say, okay, Gloria minus 10, Brian plus 10, right? And then let's say I say, oh, I want to send to Brian and Nadir. Then they say, oh, Gloria minus 10, oh, well, we received that second, so... right? You don't have enough money. And so since we're only dealing with one person, we're just dealing with a bank, they can control everything and they can look at it in chronological order. But it's a little bit difficult in a decentralized system, right? I can tell different people different things. So we're not going to get into that yet. We're first going to talk about the mechanics of transactions. So in Bitcoin, instead of having an account with a balance, each person has an account with unspent transaction outputs, or UTXOs. Transaction is TX, just to say that explicitly. So a UTXO can contain any amount of Bitcoin, and it's just money that someone has sent to you. So if someone has sent you money, it's just basically this piggy bank that they give you with an amount of money in it. And if you want to spend money out of this piggy bank, you have to smash it entirely, spend all of the money, and then you can allocate more piggy banks with it, but you have to spend the UTXO in its entirety. Now this is really easy for computers to understand because it's very black and white. The UTXO has either been spent or it hasn't been. And it can only be redeemed once, obviously. So let's walk through a transaction or a few transactions. So there's me and there's Brian. I have a couple UTXOs. I have one with 5, I have one with 1, just pretend that says 1, and I have one with 2 Bitcoins. And then Brian has some and Jillian has some. So I want to send 4 Bitcoin to Brian. So I take this piggy bank with 5 Bitcoins in it and I smash it. And I send 4 to Brian and 1 to myself. So basically I just spent all the money in that piggy bank. There's still the same amount of Bitcoins in the system. It's just now Brian owns 4 of it and I own 1. It's like very easy. It's just like change, right? I use a $5 bill and I get $1 bill back, right? So this is easy to understand. Yes? Can I get a nod of heads? Yes? Okay. Just to drive the point home, we're going to do another transaction. So Brian wants to send 5 Bitcoin to Jillian. So he uses 2 UTXOs, he smashes both of them, and he sends 5 to Jillian and 1 to himself. So there was 6 Bitcoins in the input and 6 Bitcoins in the output. We use the same amount of Bitcoins. No Bitcoins were created, no Bitcoins were destroyed. It's the same amount, it's just now owned by different people and in different UTXOs. Yes?
What's the utility of sending it to yourself?
So the idea is like change, right? Let's say I only have like here, Brian has 6 Bitcoins, right? He doesn't want to send Jillian all 6 Bitcoins. So he has to spend all of them, so he sends 1 back to himself. That makes sense. Yeah. Okay. Yes, question.
So is the number of Bitcoin in one UTXO fixed?
Yes, it is. Yes. So the question was whether or not the amount in a the amount of Bitcoin in one UTXO is fixed, and yes, it is a set amount. What you can do is spend that UTXO and split it into other UTXOs. Or you can take 2 UTXOs and put them together and create a new UTXO. It's like piggy banks. Yes?
Is it true for other cryptocurrencies like Ethereum as well?
It's not true for Ethereum, but for many other cryptocurrencies, this is the model they use. Yes? Your
What's the
question?
motivation behind this?
This is very simple to code and easy for computers to understand because it's very black and white.
Like, why not just like I have X Bitcoins, X minus however much I want to pay for this person?
So,
Because it seems like more complicated than that.
so in this case, it's very easy to see whether or not you have spent this amount of Bitcoin already. So like for the example I said before, let's say I want to send the same money to both Brian and Nadir. So in this case, they would be able to say, I explicitly sent this particular UTXO. It has like an ID number on it. And I already spent that one on Brian. So it's very easy to see that if I try to send it to Nadir too, there are conflicting transactions.
Okay, so it's for the security.
It's security, yes.
Okay, cool.
Another question?
Do accounts have caps on the amount of UTXOs as well?
No. Do they? I'd highly doubt it. Yeah, no. That wouldn't make sense, yeah. Another question?
How does the process work if you want to, let's say, break a UTXO of 100 Bitcoin and just make it into 2 piggy banks and send it to yourself?
So you can do that. You would say Gloria to Gloria, 50 Bitcoin. Gloria to Gloria, 50 Bitcoin. Or actually, no, it would look like this. So actually, I might use this board actually right here. So the way that a transaction looks, I just don't have a slide on it, so I'll just draw it for you. So let's say you have, like, this is your transaction. So this is you, it's Gloria, is the sender, and then I write like my signature. Basically, I like sign it or whatever, right? And then I say the inputs are UTXO number 1, 2, 3, 4, 5, right? And it has a total amount of 100 Bitcoin. Then I say my outputs are UTXO number 5, 6, 7, 8 to Gloria, or redeemable by Gloria. Redeemable by someone's signature that equals to Gloria, basically. So if the signature is signed by Gloria, then that means you can redeem this. Then I have UTXO number 7, 8, 9, or whatever, right? It's also redeemable by Gloria. Does that answer your question?
Yeah.
In the third lecture, we will go into more detail on exactly what the script looks like. So that might make things clearer for you. I just can't fit everything into this one lecture.
I actually want to follow up. So, like, is there any like security advantage of having a UTXO containing like less Bitcoin or more Bitcoin, or is there like a particular reason why people want?
No, it's just that while you're transacting, you're just gonna end up having different amounts of Bitcoin and UTXOs. Yeah. All right. So that's it for transaction. Oh, you have a question.
What exactly are signatures, like the forms of?
So that involves some cryptography and stuff. I'll talk about it in lecture 3. Are you okay with holding on to that? Okay. Yeah.
Why can't we just use a lock on an account to solve the double spending instead of?
Sorry, why can't we use a what on an account? A lock? What do you mean by that?
Like we learned at 162, like a lock on an account. So basically, like when we trying to like double spend something, we'll put a lock on the account until the first transaction gets finished, and then we process the second transaction. Why don't we do that?
Right. I haven't taken 162, but I kind of get what you're saying. So the question is what if, let's say there's double spend, where first, when we receive the first transaction, we lock it, and then so we make sure that when we receive the second transaction, we have already seen the first transaction, so we won't process the second one. Is that what you're trying to say? Okay, so double spend problem mostly is in the nature where, let's say I have, this side of I'm connected to this side of the room as well as that side of the room, and so I tell this side of the room that I'm sending the money to Brian, and this side of the room that I'm sending money to Nadir. So it's not necessarily that I tell both things. It's that there's conflicting information because not everyone knows what's going on. That's kind of the nature of decentralized networks, is you're not guaranteed that everyone is on the same page at all times. Does that make sense? So this wouldn't be a problem if, say, it was a central database where this database received all the transactions. But that's not guaranteed, right? Because we're a peer-to-peer network. Hopefully I'm answering your questions, but if you have more, we'll talk about it after class. Okay. So this is the third part, the record keeping, the blockchain. So after we have all this transaction data, how do we store it and make sure that it's not going to be changed later? So in a traditional bank model, we know that the bank basically has some kind of central database where they store all this information. And we're going to trust that there's some kind of security measures to make sure that nobody's going to hack into the database and set my account balance to 0 or give themselves $1 million or something. And maybe they have multiple copies to make sure that if one server goes down, they still have something that's available for other people to see. But anyways, one thing that we know for sure is that the bank keeps the sole copy of the data. And if we disagree with what the bank says, sucks us up because their truth is the truth. Now in Bitcoin, it's a little bit different. So I took all the transactions that I just talked about in the last few slides and I put them into a block because it would be very tedious to have to broadcast transactions one at a time all the time, right? So usually in banks, they're dealing with thousands of transactions per second. Obviously in Bitcoin, this doesn't really happen because not as many people use it, but still we want to batch transactions into blocks to make them easier to deal with. So in this case, we put them in blocks and then every 10 minutes, we add it to the blockchain. So every 10 minutes, we're going to add a new batch of transactions to the blockchain. So how do we store this? Using a distributed database. So the idea is instead of having one person control all the data, we want to steer away from the central entity as much as possible. So we want ideally for everyone to have an equally legitimate stake in, equally legitimate claim as to what data is accurate. Now this is a little bit difficult to do, obviously, but the idea is everybody can store a copy of the blockchain, and everybody has an equally legitimate claim to it. So there is no one person to hack. Let's say we all store the copy of the blockchain and someone hacks me and now I have really wrong data. But it doesn't matter because I'm just one person in the network, and all I have to do is say like, hey, can I have your copy of the blockchain? Can I have your copy? And I'm like, okay, yeah, now I have the new, like I have all the updates. And if someone wants to join our network, they can just ask around for the blockchain and say, okay, yeah, now I'm on the same page with everyone. So there is no central point of failure. That's what we mean by central point of failure. You can't bribe or hack someone in order to suddenly change what the truth is in a blockchain network. Does that make sense? Okay. So we'll talk more in the third lecture about exactly how this works and why blockchains are immutable and all that. It's a beautifully designed data structure in my opinion, but you have to wait 2 weeks. All right, any questions on blockchain? Wow, really?
Yeah. So there was a guy coming to ask a question before that I didn't really get the full answer to, but say your small group of people has I don't know, X amount of blocks in it, and someone kept like adding on more blocks, wouldn't you eventually run out of storage because it's being held across certain points, right? The data is being held across multiple points, but eventually, like, there would be a finite amount of storage, wouldn't there be?
So the question is a concern on the blockchain getting too big?
Yeah.
Okay. So
like if there's a small number of people in the blockchain.
Small number of people in the blockchain.
You gave an example where you had like Nadir, Jillian, across those 5 people, if the blockchain gets too big, wouldn't you run out of storage?
I don't know if that's really a concern of running out of storage. There is scalability issues with the blockchain growing with each day. There are ways where you can store like a condensed version of the blockchain, but still have accurate records. But the idea is as long as a good number of people are storing a complete history of the blockchain, then we're good because we can always kind of not really centralize it, but rely on them to like keep up with the information, and then we have our own like little smaller version that's equally accurate. Does that make sense? So yeah, the scalability is an issue, but I don't know if running out of space is really the biggest problem. Yeah, it is. It does get big, but we have space. So right now, I think the Bitcoin blockchain doesn't. I don't know the exact number. Nadir, do you know exactly how big the Bitcoin blockchain? 173 gigabytes. So that's easily fittable onto like this computer, right? So yeah, a lot of questions. I'll start here.
Is that like all those gigabytes of the history of the blockchain? Does that go all the way back to like the beginning of Bitcoin?
Yes, from like 2008. Yes. 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 Back there, I saw first.
So, Gloria wants to give Brian money, but where does that money come from? Like, I know, practically speaking, Gloria pays dollars to get Bitcoins. Somebody has the Bitcoins, and they send it to her. But, like, where are the Bitcoins coming from? Where do they originate?
Yeah, so that's a good question. The question was, where are the Bitcoins originally being minted, right? So where are the OG Bitcoins being had or being created? Because someone sent it to me and then I sent it to Brian, right? Okay, so the idea is every 10 minutes, every time we add a new block to the blockchain, a new batch of Bitcoins is created to whoever put that block on the blockchain. So every 10 minutes, there's right now 25 Bitcoins being added to the network. So, and that's the only way that new Bitcoins are created. Yes?
So, if a block is added every 10 minutes, how do you make instant transactions? How can you pay for coffee if the transaction is only going to be in the block in 10 minutes or you need the other block?
Right. So, so the question was, how do I make instant transactions if transactions are only uploaded to the blockchain every 10 minutes? And the answer is, I guess, transactions are not instant in that case. And you could say that is a flaw, but you could say that once I've broadcasted my transaction, as long as I trust that there isn't someone out to get me and someone who's going to invalidate that transaction, we can trust that it's going to go through at some point. Yeah. It does rely on other people, of course, but
the person who's supposed to receive it, can he see that I broadcasted it, even though it's not in the blockchain?
Right. So when I broadcast a transaction. If you're my peer, then you'll receive that transaction, and the idea is it will propagate throughout the network. Because we're all interconnected, and as soon as I get a transaction, it's valid. Okay, I send it to the next person. Yeah. Okay. Another question.
Yeah, before we were talking about like Gloria as the anonymized key.
Yes.
Who is storing? If it's not a one-to-one, you can create multiple keys. Who's storing the block in this case, right? Because there's all these different parties that are all anonymized.
Well, so you have your computer, and it stores the blockchain. And then when you propose new blocks and you propose new transactions, you'll assign one of your identities to it. So your address or whatever, or your signature will be on it. It doesn't really matter which one of your identities does it, but you're the only person who can actually sign off on that thing. So yes, there is the fact that, it's not me, it's not Gloria. It's like Gloria's, it's not Gloria, it doesn't say Gloria at all. It says like, 1, 2, 3, 4, 8, 6, whatever, right? But it's still like that accountability is still there, where there is a person who is guaranteed to be authentically 1, 2, 3, 4, whatever, is signing off on this. Does that answer your question?
Yeah. So the record is really validating through your hard drives, and that block is consistent with both other blocks. And I am making the transaction.
Yes. Yes. Question.
Yeah, I heard that maybe there's like a set number of bitcoins you can mine or something.
Yes. So, like I said, every 10 minutes, right now there's 25 bitcoins that's being made every 10 minutes. Every new block that is added to the blockchain, there's 25 bitcoin that goes to the creator of that block. It used to be 50. In a couple of years, it'll be 12.5, and then it'll be 6.25. And then it'll be 3.125, and it's gonna have every 4 years, I think, every 4 years, and I guess like asymptotically it like reaches, is it 21 million or 21 million? Yeah. So like it reaches a limit, and it just happens to be 21 million. It's just an arbitrary number. Yeah. Another question. Yeah.
If your public key gets tied to your public identity, like in real life, does that mean that anyone can see how much money you have and who you send money to?
So your public key is not actually tied to your public identity because, like I said, there's no personal information that you need to enter in order to create an account on Bitcoin. That being said, if, let's say, you are on Coinbase and you go to Coinbase and you say, I want to withdraw money. Like, I want to trade you these Bitcoins from this address for this amount of money. Coinbase will send money to your credit card or your bank account or whatever, and then that'll be the link between your Bitcoin account and your real life identity. But just Bitcoin alone does not keep track of any personal information.
So Bitcoin has a record of all transactions since it was created.
Yes.
Is there a security reason for that, or it's just why not?
Right, so basically you need to keep track of all the UTXOs. So like I said, we have a lot of these transactions and we just keep track of the outputs, specifically the unspent transaction outputs, right? So the reason we keep a track of all of the transactions is so that we know which one of these have been spent and which ones haven't been. But like I said, there's a condensed way to keep track of blockchains. So for example, you could just keep a list of all the unspent transaction outputs, all the UTXOs, and you would be able to validate transactions. Does that make sense? Okay. Another question?
I suppose since there's so many transactions being made, like two versions of the chain can't possibly be completely identical. In that case, if they're both equally trustable, then which one is correct?
All right, so the question is, let's say we have different people have different blockchains. How do we decide which one's correct? Okay, so that's what I'm going to get to next, how we come to a decision. The idea is we're all going to decide on one blockchain. If let's say you decide you want to have a different blockchain, but everyone around you decides to go with something else, then you're just going to be like a loner dude like with your own blockchain. It doesn't make any sense. So the idea is we all want to try to be on the same page, because it doesn't make sense for you to be in your own little world, because you're just going to get left behind. So we try to keep on the same page. In the case where it's like a 50-50 split, or there's a large group of people who are like, no, like, we're going to keep this version of the blockchain and you guys have your own version, then that's called a fork. And forks do exist. Bitcoin itself actually has a fork, which resulted in a software difference between two different blockchains. But it does happen, but it's very rare. Mm-hmm. Sorry, you've been having your hand up. 12.5. Oh, 12.5 is right now? Okay, my bad. All right, another question.
Do the blockchains for the different coins work differently?
A lot of them are like different flavors of blockchain, but most of them borrow directly from Bitcoin. Yeah. Yes. Mm-hmm.
Whatever the current identifying store value.
Yes.
In any other case, how does it happen to it?
So you're asking, are there other examples of when it would not be anonymous?
Are there examples of converting from blockchain to some other currency that is anonymous?
Oh, that is anonymous. I'm sure there are services for that. But if you're going to, basically, let's say I set up some kind of anonymous service where I promise you that I will exchange you money for your Bitcoins. That, because we deal with fiat currency then, that would be very illegal. Like Coinbase, for example, is very heavily regulated. They're required to know personal information about all their customers because of tax purposes as well as like, legal reasons. So I'm sure that is possible, like it can exist. I'm probably sure I can like set up a company like that right now, but I would get shut down like really quick. Yeah. Okay. Is that all the questions? All right. I'm not even going to look. Let's just move on. So let's talk about how we make sure we're all on the same page. And this is a consensus protocol known as proof of work. So it doesn't work if we all have different blockchains, right? We should all have the same blockchain. That's the idea. And in the traditional model, let's say, how do we decide which transactions are valid and which transactions to add to the ledger of truth? With a bank, it's very simple. We just ask them to do it, and they do it for us. We say, hey, bank, like Bank of America, like I want to send this much money. And they say, oh, okay, it's valid, Okay, sure. It's in the record now. So it's very easy, like very easy. It's very difficult when we have a decentralized model. So let's try the naive approach first. So let's say I want to send a transaction. So I tell the person, hey, I'm sending 10 Bitcoin to you. And I tell everyone around me, hey, I'm sending 10 Bitcoin to Brian. And they say, okay, looks valid. Okay, I'm going to put it in my blockchain. And then I say, hey, I'm going to send this one. And they go, okay, I'm going to put it in my transaction, right? So does that work? Do you guys think that's going to work? If we just look at it, make sure it's valid. It's valid. So should it work? So I said the word naive. So the answer should be no. So here's an example. This is something that I said very early on. Let's say Jillian promises 10 Bitcoin to Brian, and she promises 10 Bitcoin to Nadir, and it's the same Bitcoin. And they both say, oh, looks valid, yeah. And then Brian also says, looks valid, yeah. And then so now they have the same Bitcoin. Basically, they stem from the same UTXO, but they're not going to know until they try to spend that money, and then suddenly people are like, wait a minute, like you two have conflicting transactions. That's not cool. So what went wrong, right? This is malicious activity. It's a doublespend attack. So what went wrong? We didn't look for confirmation from the rest of the network that this was a universally accepted truth, right? We want to make sure that everyone's on the same page. All right, so instead of every person making their decision all by themselves in a silo, let's have people propose new blocks, and then let's all vote on them. So the way this will work is I take all the transactions that I heard in the last 10 minutes and I propose this block to everyone. And then we all say, okay, looks like all the transactions are valid. And then let's say, you know, there were 10 different blocks that were proposed in the last 10 minutes. And then we're going to vote on which one we accept. So does this work? Do you guys think this? Hands up if you think it works. Okay, we have a few takers. All right. So let's test it. Now, Jillian tries to double spend, right? She's going to be rejected by her peers. They're going to say, hey, Jillian, I see you trying to... Brian just told me that you tried to send 10 Bitcoin to her too, right? Nadir's going to be super pissed because it's like, what the heck, man? You're trying to send us the same... You're trying to double spend, right? And they say, oh, we're going to vote no. So we're going to reject Jillian's transaction. All right, so we're all out voting Jillian, right? It's like 4-1. Nadir, Nick, Brian, and I all say, Jillian, no. And she only has one vote, right? So 4-1, we win. Majority rules, right? So let's think back to what I said about identity, where you're just generating private and public keys. And how many can you make per person? Yeah, right? So let's say Jillian just says like, all right, I can make as many as I want. Like, I think it was like, if you split it between everyone, then each person gets like 2 to the 127th, right? So let's say she makes that many accounts and she votes with all of them, right? Then she can outvote us. And she's like, screw you guys. Like, I can spend as much money as I want. I can double spend, triple spend, quadruple spend, right? So like, what's to stop her from doing this, right? This is called a Sybil attack, where someone makes a lot of multiple identities to do some kind of malicious activity. So how do we solve this? Does anyone have any ideas first? Anyone have any ideas? Yes.
How much skin you have in the game?
Ah, so how much money you've invested into Bitcoin? Yeah, so there's models like that called proof of stake, where you have to basically stake some of your cryptocurrency in order to vote. So that's a solution. So basically, what Satoshi Nakamoto came up with was basically we need to tie voting power to something that is not to something that is expensive, something that is scarce. And so he said, let's have people provide evidence that they've spent resources on this eligibility to vote. So each vote has to be tied to some kind of limited resource that you have. And that limited resource is not going to be identities. It's not going to be how many accounts you have. And so he said, let's tie it to computational power. So in order to propose a block, you need to provide proof of work, evidence of spent resources. And so you need to provide a solution to a hash puzzle. So you compile all your transactions into a block, and then it's like da-da-da-da, you know, there's all your transactions. You also need to provide a proof of work. Without this proof of work, your block is not valid. And the way you provide this proof of work is you solve a cryptographic hash puzzle. This hash puzzle can only be solved through brute force computation. This is a cryptographic concept where there are some problems that you can only solve by forcing your computer to just plug in as many numbers as possible and just go through the list. And it takes about 10 minutes to do that, right? And it spends energy and computational resources in order to provide this proof of work. And so this process of solving the cryptographic hash puzzle and putting them together into blocks is called mining. And the reason it's called mining is because you spent all these resources, there has to be some kind of reward. And like I said before, it's 12.5 Bitcoins now. So each time you propose a block and it gets accepted and it is added to the blockchain, you get 12.5 Bitcoins. That is your mining reward. And so the whole analogy behind mining is you're doing some kind of work to get some kind of, you know, raw material ores or some valuable metal from the ground. But in this case, it's Bitcoins. So does that make sense? We all know what mining means, in case you've heard it before. Now we have an idea. Yes, question.
Are you rewarded for voting on the blocks as well as proposing them?
Right. So the idea is when you propose a block, you're voting for yourself, basically. So instead of really people proposing blocks and us voting on which one we want, it's kind of like I'll propose a block, and then if I'm the first person to do it, and I broadcast it to as many people as possible, they'll say, oh, okay, this is a new block.
And they also propose that block.
They just accept it. So there's only one proposer of a block because you're the person who like kind of put it together and you provided your own proof of work. And then as soon as someone sees that block, they're like, oh, okay, like I'm going to take this and put it on my own blockchain. And the idea behind that is if you're a participant in the network, let's say you're mining your own block and someone has already come out with their own block. Are you going to continue like trying to make your own block, or are you going to start on the next one, right? So you want to be on the same page as everyone, and if you fall behind, that sucks for you, right? So you always want to have the newest information. So as soon as someone comes out with a new block, you're going to want to take that. Yeah. You got a question too?
Does everyone test the solution on all the like transactions they heard broadcasted before they added to their own blockchain?
Yes, you would verify that the block is valid. Yes. I saw a question here.
So you said that the 12.5 Bitcoins gets awarded to the miner only after the block has been accepted.
Yes, so it would be one of the, it's called the coin-based transaction. It's one of the transactions included in the block. So you have like, you know, Jillian spent this much, Gloria sent this much, as well as this much Bitcoin was created and sent to me.
But how does the protocol know when a block has actually been accepted by the network?
So basically it doesn't. There's no like centralized person to say like, this is the new information, right? It's just everyone who has your block has the information that you have this new Bitcoin. Does that make sense? So it's like, let's say you're like writing a history textbook, right? And you write down everything that happens every single day. And then the new page, you add a new page to your history textbook that says like, oh, by the way, like this person got 12 Bitcoin. As long as everyone adds that page to their book, it's part of their history now. Yeah, that makes sense. I see nodding heads, so that makes me feel good. Nadir?
Can I add something on what you just said?
Yeah.
So one way that you don't explicitly vote, as Gloria said. The way you implicitly vote is by building off the block that you post. And as Gloria might mention later, that it's the longest chain, which defines the truth, right? It's the one that everyone's mining on.
Mm-hmm.
So if you agree with the block, you mine on top of it, you give that block more support, so to say. And if you refuse to mine on top of it because it contains more transactions, and everyone agrees to refuse to mine on it, then it's been excluded from the longest chain, and therefore won't be considered valid.
Yeah, so to kind of summarize what Nadir said, the accepted truth blockchain is the longest one because it's had the most work put into it and the most people basically backing it up. Yeah, okay. I don't want to misrepresent. Yes?
So you're saying people have to add a certain transaction to their own block, and people choose not to do that.
I'm sorry, people have to add what?
So people add a certain transaction to their blockchain. Right?
Add a what transaction?
A block to their own blockchain.
Yes, so they add the new block to their blockchain, yes.
And people choose not to add.
And people can choose not to add their blockchain. But the idea is, unless there's something blatantly wrong with this block, there should be no reason for you to reject it because everyone else is going to take it. That make sense? Okay, you.
You said that it's computationally expensive to propose a new block. In that case, not everybody can propose a block, right? In that case, then like it would still kind of be centralized because that the certain people who are capable of producing or proposing a block would become like the center of people who aren't.
So the idea, okay, so the question was, if it's computationally expensive to produce a new block, then not everyone can produce a new block, right? So the idea is you are still incentivized to do so because there's that mining reward that you want. So you will still mine for that block. It's a competitive process, and the idea is you want that reward. So you're going to still mine.
But couldn't you still kind of formulate your sort of new bank where like somebody can make profit out of just simply not letting other people give their transactions to them, and then they're proposing, I guess, their own.
Right. So you're saying you can earn money being a miner.
Yeah.
Yeah. So people do that. There's a lot of companies that exist that create ASICs, which is just hardware that helps you mine Bitcoin faster. And because it is a competitive process and because there's economics incentives behind it, there's a lot of competition. So let's say I come out with a faster computer. I start using GPUs to mine. Then you're like, oh, well, because it's like profitable, like I'm going to use a GPU to mine. And then pretty much like everyone in the room who wants to make a profit is using more and more like sophisticated hardware. So the idea is you're asking if it's centralized because one person is going to mine all the Bitcoin, but no, because there's that economic incentive, a lot of people are always going to want to mine. Does that make sense? We have a mining lecture, lecture 4, so that might answer some more questions. Yes.
Yeah, you talk about how the blockchain is broadcasted throughout the network. Because how do you verify? How do you know whether something is true or not? Like, if I know that it's like a malicious activity, right? So how do you tell the rest of the network that it's wrong?
Well, if you were to detect malicious activity, I would assume that other people would too.
So like how does the process go? Like how do I know whether it's right or wrong?
I guess Nadir has an
This
answer.
comes back to the longest fork idea. Let's say that for whatever reason, you individually see something as incorrect. If you're mistaken, you'll quickly find out everyone else accepts something else because the longest chain is something that you disagree with. So at that point, either you split off to your own fork, which will only be supported by you, or you go into the longest chain, which is the honest majority.
So like let's say like Jiren sends Bitcoin to Nadir, right? And let's say Jiren sends to Bill. So only Bill and Nadir knows that it's wrong. So how does the rest of the network know that it's wrong?
Well, that transaction would probably get to everyone else as well. Because for it to be accepted by everyone else, Jillian would have to send it to everyone else.
Oh, okay.
I feel like the question raises because it sounds like all the miners do is to do the computation and they don't actually observe what's going on in the entire chain. So how do they know like the transaction goes wrong? Like how do they make the decision to like
Include a transaction or not? Yeah, so I think in the protocol, you would only be accepting a transaction if it checks off the validation boxes. So like, you know, this money hasn't already been spent before, the signature is valid, all of that. I think that's built into the protocol. So there's no like, you wouldn't accidentally accept a wrong transaction, if that's what you mean.
The decision-making process actually don't often happen?
The decision-making process does not, it happens quite regularly because we're always updating with new transactions.
So does the voting process actually happen, or everything is guaranteed to work perfectly by the design of this?
By the design, I would say it works pretty well. Yeah. Okay, you have a question?
Is it a human process or is it done by the computer?
Done by the computer. Yeah. You have a question?
One thing I don't understand, just if you have enough computational power, then you are free to mine, and you're free to like mine as many Bitcoin as you want. But like, I'm just thinking from like traditional perspective, will that cause like inflation if you have too much Bitcoins and just because currency is basically free exchange materials.
Right. So the difficulty of the computational or of the cryptographic hash puzzle that you have to solve changes so that on average it'll take you 10 minutes per block. So let's say, I think it's every 2 weeks, the difficulty is tweaked a little bit to make sure that blocks only are happening every 10 minutes. So to answer your inflation question, there wouldn't be a sudden, like, I don't know that much economics, but there wouldn't be like a sudden increase in the amount of Bitcoins in the network.
But like gradually increase.
Gradually it increases, yes. So, I mean, by definition of inflation, like, yes, like, maybe, I guess. But, yeah. Yes, question in the back.
I just want to clarify, it's hard capped at 21 million.
Mm-hmm.
The circulating amount is like 17 million currently, so there's no inflation in that. It would naturally be deflationary in that we know the eventual number of Bitcoins. So an economics perspective, even if someone mines all the Bitcoin for a day, they're only getting 12.5 every 10 minutes, and it's only going to reach this amount.
So you're implying that just there are just so many Bitcoins out there, and only those people who want it.
Yeah.
Like, no, they're not taking it from. They're not creating it like out of nowhere. They're just like getting.
They're getting part of a hard cap.
Any other questions? Oh, how do I choose? Let's start from this side.
So what happens with the incentive to mine disappears when you hit the cap?
Right. So the question was what happens when we hit the cap and the mining reward is very little? Then what's the incentive to mine? So more and more they're starting to have transaction fees. So you'll add a little bit of money, a little bit of Bitcoin onto your transaction for the miner to claim. And so that would be incentive for the miner to include your transaction in their block because they get the transaction fee.
I have a syllabus-related question. So will we go over the math and coding in future lectures? I feel like, shut up, just give me math. I feel like if we were able to, like go over the actual algorithm background, then those stuff can be more clear and easier to understand. Like now it sounds.
So you want more explicit like proofs and that kind of stuff.
Yeah, math and code and stuff. Will we go over that type of stuff?
Yeah, we can provide that. Yeah, I mean this is literally called high level overview. We do dive deeper, but depending on how deep you want to go, we can always help you. Yeah. Red.
Who creates the hash puzzles?
The hash puzzle, basically what the hash puzzle, we'll go into this later, but what the hash puzzle is, you take the hash, do you know what a cryptographic hash is? Okay, so you might want to wait until lecture 3, because it's a long explanation.
So, is it like computationally generated, or like
It's generated automatically, yeah. It's basically like, let's say, think about it this way. So like, let's say your block is like this little like puzzle piece. You have to basically create the missing piece of the puzzle. Like think about it that way. Yeah. Okay. So yeah, like let's say you basically have to like keep generating like random like shapes until one of them fits perfectly into this puzzle. That's kind of the idea. Okay. You first.
Is there like a benefit to the puzzle, or is it just like for verification?
It's just for verification. It's just for the proof of work. Yeah. And you?
I'm slightly confused. I got a lot of data from this, but so when you said the difficulty is being tweaked,
Yes.
who is tweaking it? Kind of how?
It's built into the protocol. Let's say like, so we're making different like, we're generating all these pieces and we want it to fit perfectly into this block. Just pretend like I'm hand waving over a lot of stuff. But basically we want the piece to be like blue or something like that. Or like, that's a bad way to explain it. Okay, so basically your solution is going to be like 0, 0, 0, 1, blah, 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 right? And then so the way that they make it harder is they say you want to have more zeros in the beginning. So it doesn't, there's a lot of context involved. I have to explain to you exactly how the hash puzzle works. So we're going to talk about that in lecture 4, I believe. But you basically, just wait until lecture 4. I'm really sorry I can't explain it all right now. Yes?
How does, because you mentioned the mining process is really competitive, how does the system decide who gets to mine that block?
Anyone can.
Prioritized through, who's involved in the direct mining?
There's no prioritization. Anyone can mine.
Okay. So can there be, multiple miners on the
Yes? Yes. Yes.
Just have
Question.
Just because you mentioned traditional model, so in traditional model, I just want to ask, comparison of block, are you trying to facilitate a transaction, or are you trying to get Bitcoin? I understand what I mean, because you mentioned
Right. So, okay, so you're asking when you're mining, are you trying to facilitate transactions or are you trying to get the mining reward? Okay, so the idea is incentive alignment. So they make it so that those two are incentivized in the same way. So if you do one, you're doing both. So if you do this, then you get the mining reward. Yeah.
Isn't it very cumbersome just every time you want to send Bitcoin to someone to solve it?
It's the proof of work idea. So you need to prove that you've spent resources in order to propose a block. Otherwise, we would be back to square one where we're just randomly using identities to vote on which block is valid. And we have to have some way of making sure that each person only gets one vote. So we need to make voting expensive. If it's too easy to vote, then the system won't work.
But won't it create like a liquidity problem? Just like if you don't have computational power, you cannot really send Bitcoin to someone?
You can. So you can send transactions even if you're not mining. You would just be sending it to a miner so that making sure that they include your transaction in their block.
It's like an agent trying to get miner.
Yes.
And he or she will facilitate.
Yes. Yes. Okay, so I'm going to stop all questions right now because we're running out of time. What I really want to do is just prove to you that this works. So basically the idea is Jillian has as many identities as she wants, but she still only has the same amount of computational power, so she can only vote as one person. So there's no malicious activity. Yay! Okay. So I'm very sorry. Like, ask your discussion leaders like your questions. Yeah, so we only have a little bit more than half an hour, and I really want to get to Nadir's awesome discussion questions because he spent a lot of time preparing them for you guys. And like, you can ask as many questions as you want to Nadir. You have any more questions? Post them on Piazza. We're gonna like, we love answering questions. So, and by the way, like, I'm really excited about how like engaging you guys are. Like, I've never been asked so many questions, and it's like making me very happy. Okay, so just to review, we went over the 4 components of a bank as well as Bitcoin. So the first was identity, where we use some function to randomly generate a private and public key, and we use that as our identity. You can make as many as you want. There's no checking which ones have already been used, and it's pseudonymous. It's almost anonymous. Transactions, we use a UTX model because it's easy for a computer to understand, and it makes it easy to validate transactions. Record keeping, we use a blockchain where we take blocks of transactions and store them in chronological order. We make sure that they're not mutable as soon as they're on the blockchain, and we make sure we're all on the same page using a consensus protocol called proof of work, where we tie voting power to spent resources. Right? Okay, that's what we learned today. Cool. So you can kind of explain Bitcoin to your grandma or your roommate. We all feel confident about that? Yeah? Okay, so this is another slide that I kind of want to talk about. This is more econ related, so it's less CS. So what are some things that currencies need in order to be legitimate, basically? The first thing is scarcity, right? Like, if we had unlimited amount of dollars, like, what would be the point? Fungibility. The idea is if I have a dollar here, and Nadir has a random dollar that he brought from like the East Coast, they're worth the exact same amount because they're both $1. Just because one's crumpled up or one was used to buy drugs, still, like, we have no way of telling, so they're still worth the same amount. Divisibility. It would make no sense if there was just $1 in the world and we all had to like somehow share it all amongst ourselves. I don't know how to explain this, but like, it has to be divisible. We have to be able to pay $10 as well as $2.50 as well as 1 cent. Durability. So if my dollar disintegrated in my pocket, I wouldn't want to use dollars. Transferability, liquidity, being able to send it back and forth, and most importantly, legitimacy. So we all use dollars and we trust that dollars are going to work, and today we use dollars, tomorrow we're still going to be able to use dollars. I'm going to store my money in my bank and I trust that like 10 years from now, you know, I'm saving for a house or something, like it's still going to be there and it's still going to be able to buy me that house in like 10 years or 20 years, however long it's going to take me to save enough money to buy a house. Yeah, so, sorry. So legitimacy. So how can we trust Bitcoin? This is a question that I get a lot. you guys didn't ask me this question, but which I'm really surprised of. But it's like, oh, how do we know that like Bitcoin is worth anything? Like, what gives it any kind of value? So I try to put this page up so that you're able to kind of explain it to someone if someone else asks you this question. Legitimacy is kind of the hardest one to prove, but I think Bitcoin has been tested over the course of 10 years, I guess now, and it's still working. So, you know, it looks so far so good. All right, and the last thing is enrollment. I wanted to make sure we got to this. So tinyurl.com/fun-decal-enrollment. You need to be logged into your Berkeley email to do this, which makes sense, hopefully. And once you've filled it out, I'll give you an enrollment code. So I kind of went through the old-fashioned way, and I like printed them out and like cut them up. So I'll just basically hand you a slip of paper. So once you filled it out, just I guess come up to me and I'll take your name down and give you a code.